Good morning, fellow South Africans. Today we are here with the grade 9 class and everyone watching, tuning in from the rest of the world. Today we'll be looking at functions and graphs. All right, so we're looking at the standard linear function. And we have here an instruction, and we're going to do this instruction by an example. All right, so there's a lot of things that is going to happen within this example. So if it's new to you and it's here, it's your first time that you're seeing this topic, don't be alarmed or don't be afraid. We are afraid. We are all here to learn and engage with the topic that we have here. All right, so we are given the instruction in which of the following graphs, sketch below, in each of the following graphs, sketch below, determine the equation of y, determine the equation in the form y is equals to mx plus c. All right, now remember, this is actually a formula. All right, that you should know. And if you continue with mathematics, this is a formula that can be used in mathematical literacy as well as mathematics. So, which either option you choose, this is going to be important for you. Either way. Now, let's go break this up quickly. And we have already done some theory. So, if we talk about the m there, can everyone see the m? Right, so the m there indicates the gradient. And if we talk about the gradient or the slope, and I want to quickly take your mind to when you're walking uphill, all right, we are basically determining the steepness of a hill or the inclination of a hill when we're talking about a gradient. So when we're talking about a gradient, which we use the variable m for, we say m, which is the gradient, can be determined, and physics. Now, I'm first going to work from physics, right? Those of you who have natural science, maybe some of you like the natural science and you want to next year go into physics. Then in the physics, they talk about the gradient of a line gets defined by the distance of y over the distance in x. All right? But in mathematics, we try to simplify this and we say, if I have two coordinates, now what is a coordinate? Right here we have a Cartesian plane, and this consists out of an x-axis and a y-axis. And right here I have the coordinate, that point right there is the coordinate of 0, comma point 0. Why do I say that? And we call this the point of origin, because it's where everything starts. So this can also, all coordinates gets classified in terms of an x coordinate as well as a y coordinate. And if we go and we have certain coordinates which is identified to us, like this coordinate where it cuts the x-axis at 2, and this coordinate cuts the, which axis? The y-axis at 4. So when we write down the coordinates, I want you to help me write down the coordinates of this in terms of x and y. Let's go with the 2 first. What is the x value there on the x-axis? The x value is 2. Who can tell me what is the y value of the 2? What is the y value of the 2? So now we go, okay, let me just do something for you. So remember, this is 0. I'm first focusing on the x-axis. All right? And this is the point. Let me just see. All right. This is the point 0. Alright, if we move right, we're going to have 1, 2. Okay, that's not on scale. Let me just put it to scale quickly. So this is the point 0. I'm moving on the x-axis. So there would be 1, then we have 2 there. Then there would be 3, 4, and we continue. As we continue right, it will go on until infinity, and that's actually what the arrow indicates to us. But if I go back to 0, and I want to go further to the left, what will I have? Negative what? Negative 1, negative 2, negative 3, negative 4. Everyone is clear on that. It's almost like the number line. And that is for the x-axis. Now, according to our alphabet, x comes before y. Now we're going to our y-axis. So this is also, once again, the point of origin, starting from 0. If I go up, that will be 1, that will be 2, that will be 3. And we can go further, 5, 6, 7, 8, 9, 10, 11, 12. We can even go to 100 if space allows us. But in our books, we're not going to go so far because our space is a little bit limited. All right? And if I go down again, up until the point of origin of my y-axis, and I go down, I'm going to have negative 1, negative 2, negative 3, negative 4, negative 5, and so I can continue until negative 1,000 if I have the space. Okay? So I'm just trying to paint that picture to you. Now I'm going to ask again. This coordinate where 2 cuts the x-axis, what is the coordinate? It is, we know the x value of that coordinate is 2. What is the y value? The y value here, if I take a ruler, I'm just going to see if I have a ruler here so that you can see perhaps, where's my ruler? Let me just see if I can find my ruler. There's a ruler. Okay. Alright, so how do I change this ruler again? Alright, struggling to change the ruler. Alright, but anyway, if you keep the ruler vertical. How do I change this again? I'm going to figure it out next video. I will show you how I change this. I know there's a way. Okay, but anyway, so you keep your ruler vertical, all right? And then you ask, where does this, not this one, sorry. What happened now to the line? Oh yeah, this is the one. Not that one? It's this one. Yeah. So what happens to this line? We said now the x is 2, but the y is? What is the y? What is the y? 0. So the y there is 0. I'm just going to go up. Yeah. Alright, the ruler is not the ruling today. Let me just see if I can fix that. Just hold on. I want to quickly see. Alright, so the ruler is ruling again. And now we're back. Sorry there for the technical errors that we have, but I do hope you guys are still following. So there the coordinate is, once again the wrong. Now it's the wrong. It's this one. The coordinate here is 2. Alright. Now if we go on the y-axis, that correlates to what? What is the y value there of the y? 0. Alright. Now check again. Because you're checking on the y, what is the 0? Let me just take it down. You see there? What is the y there? It's 0. It's 0. On this axis, what is it? It's 0. That's why we have the coordinate of 2 and 0. And what is the other one? Let me just bring this one down, man. This one is supposed to be there. Alright, now I go to 4. What is the x coordinate of that 4? Who can tell me? What is the x coordinate of that 4? The x coordinate, well done. Beverly says the x coordinate of that 4 is 0. And that means the y coordinate is 4. Alright? So, grasp. I know it's going to take you a little while. Quickly wrap your mind. Now we've written down our coordinates. I'm just going to zoom out quickly so that I can have a clear writing here. We have written down our coordinates. I'm just going to rewrite that for that other coordinate here as well. So I have this coordinate, which I said is 2 and 0, and I have the coordinate of 0 and 1. Let's give this coordinate 0 and 4. Let's give this coordinate, let's say this is coordinate 1 and this is coordinate 2. Okay? Now we want to determine what is the steepness of this line. And so basically we are determining the slope. What is another name for slope? Gradient. The gradient of this line. I'm going to take the ruler away. So now I'm going to write here a formula. To some of you who are very clever, you might have remembered this formula. So we're going to say y2 minus y1 over x2 minus x1. And that is the formula that we use in mathematics to determine the gradient of a line. What we're going to do further is we're going to have, for this formula to work, we need two coordinates. And do I have two coordinates? Yes. What is my one coordinate? 2 and 0. And my other coordinate is 0 and 4. So I'm going to do some substitution. What is my gradient, or what is my, of value number 2? What is my y there? 0. What is my y at value number 2? 0. Minus my y at value number 1? Minus 4. Over 2 minus 0. Let's simplify that. 0 minus 4. Great stuff. This is the cleverest class I've ever seen. That's negative 4 over 2. If we simplify that, can we simplify that? Yes. What is the answer? Negative 2. Can I simplify further? Yes. So m, and what is m? The gradient. No? The gradient is negative 2. Now, if you look at the line, is this line increasing or decreasing? Decreasing. Now, whenever I have a line that's decreasing, my gradient is supposed to be negative. If I get a positive, then I should know I made a calculation error somewhere within my formula. Alright? So, I'm not done. What was the question? Did they ask me to determine the gradient? No. They asked me to determine the equation. Alright. So, there's a second part of that. So, we know what the m is. We know what the y is. Who knows what's the y? Who can tell me what is the y again? Y is the output. M is the gradient. X is the input. And C is the... what is C? Alright, so C, I want you to copy this if you haven't already. Make a note there for yourself. Mentally, even if it's mentally. C is what we call the y-intercept. The y-intercept. Now, if you listen to that word, or if you hear the word y-intercept, have we seen a y here besides the output on our graph? Go check your graph quickly. We have there the y-axis. Alright? So if I have a y-intercept, it means it's the point where it cuts the y-axis. And where does this line cut the y-axis? What is the y value there? 4. So the y-intercept, or C, is equals to 4. Now, if you don't get this on the first try, don't worry. We're going to look at another example. So now, all I have to do is substitute into my equation. I want you to follow. So I know what is the m value. Alright, so now the x is interchangeable as well as the y. So we're going to write down, what was the equation? The given equation, y is equals to mx plus c. And all that we need to change or need to determine values for is m and c. So all that we're going to do here now is we're going to write the equation, therefore y is equals to mx plus c. But we have a value for m. What is the value for m? Negative 2. X stays x. And c becomes 4. And there I've done my first one. Alright? So that was a lot to take in. I want you to copy this. And then we're going to do example number B and C and D together as well. Now we're looking on to B. The first thing that I would do, Lalita, is to write down the coordinates. No? So the coordinates of this, who can tell me, who can help me, what is the coordinates that I have here that is known, that I can see from the sketch? Is it 4 and negative 2? But let's go to this coordinate down here first. Just FYI, this is called the x-intercept. Alright? It's where the line cuts the x-axis. The 4 one is called the y-intercept. It's where the line cuts the y-axis. Alright, let's write down the coordinates in terms of x and y. So this one is going to be negative 2 and the y is going to be? What is the y there? 0. Because it's lying on that line. It cuts the y there. Alright, this one, what is the x value there? X value? 0. So the x value is 0. What is the y value? 4. Okay, so I have two coordinates. Now I'm going to go. I need to end off. How does equation of a line look? Who can help me? Equation of a line, we said, is y is equals to mx plus c. Where we know c is our y-intercept. And m is our gradient. So we're going to first write down, what is the value of c? So c is equals to 4. What is the gradient? Let's go determine that. How can we determine the gradient? We write m equals to y2 minus y1 over x2 minus x1. Are you following? Am I going too fast for you? Alright, let's do substitution. y2, let's use the top one. So y2 is going to be 4. No? Minus y1, 0. Over 0 minus negative 2. Alright, and double minus or a negative multiplied with a negative becomes a positive. So let's simplify that. That becomes 4 over 2. And that one is going to be 2. When you look at this line, is it increasing or decreasing? Increasing. Therefore, it has a positive gradient. You see. Now we go, have we answered the question? No. We need to answer this question, so therefore we say y is equals to, what is m? Is 2x plus 4. Great stuff. And there you have actually grasped a grade 10 concept, all right, that learners struggle with sometimes in grade 10, and learners by grade 11 learners also forgot this. So, learners, the expectation now is I'm going to leave number C and number D on the board, and I want you to do number C and number D on your own. Just try it, no? Go through all of those steps, and I'm going to leave it. So, here's number C and number